And then I'm going to fill that with just some magnesium turnings. If you've ever seen magnesium burned before, it's this sort of dull gray metal, but when it lights on fire and it reacts with oxygen, it burns bright white, like if you look at it just when it's burning in air, it'll leave a pretty serious after image in your eyes. And it also burns very, very hot. So this is that magnesium going into our dry ice block. We mentioned that we're going to have this react and strip oxygen atoms off of carbon dioxide rather than the oxygen from the air, but how can I do that if we're burning in this classroom where it's surrounded by oxygen? What I'm going to do is actually sandwich this between two dry ice blocks, and then we'll prove at the end that actually no oxygen was coming into this little chamber, essentially, of dry ice. So if we walk over here, and Aaron, I'm going to need your help for this. We have our lid for the little bowl that I carved out. And what we're going to do is, Aaron, I'm going to have you take the blowtorch and turn it on. And start heating up the magnesium. This will take about 60 seconds or so. Really takes a while to get going. I'm going to micromanage here and turn that down slightly. There we go. So it's starting to glow orange. That means it's getting hot. That's still not quite the full reaction that we're looking for. But keep going, keep going, keep going. Yeah, right about there, we're good. So now we have it sandwiched. It is glowing white hot. It's spitting some magnesium chunks out, which is why we didn't want people sitting there. And now at this point, we've definitely exhausted all of the oxygen in between these two blocks. And what we're going to see is this kind of flicker, which I think is really neat, where we're actually running out of magnesium. This is kind of like when a candle burns all the way down, it gutters out. So there's this, I think, very neat flickering here. And right about now, we're probably just about out of magnesium. If I open this up too early, though, it will roar back to life and spit magnesium in my face. So I'm going to let it cool down a little bit more. That is a very fun demo, but it's not very fun for me. And let this go just a little bit more, a little bit more. And then you're probably wondering, okay, how do we know that it took oxygen off of carbon dioxide rather than the air, right? How can you normally tell that? If you burn carbon, you have soot left over, right? Well, let's look at this under the document camera. I'm going to take this over. Here under the document camera. So let's see what our reaction products were. Well, we see on the top that there is some sort of whitish stuff. That is the magnesium oxide that formed. So we know we were getting oxygen in there. And there's this neat little puff that's shaped about the same size as the depression. There's all that gray and white junk. But when I split this open, I'm looking at it, we have a bunch of carbon, which we could only get if we were actually pulling the carbon, or pulling the oxygen off of the carbon dioxide that it's surrounded by. So if you didn't believe the reaction stoichiometry that you looked at before, there's proof for you.